I didn't record any of that. So if you're just tuning in, I did all this work without saying a word. You'll have to figure it out on the next problem. But anyways, I factored out the mass, leaving me with V final, which is positive 90, minus V initial, which is 0. The ball is at rest before the club hit it. Now the question first asks for us to find impulse. Impulse can either be all of this or all of this. So if you have a side that is complete and that you have everything you need to compute change in momentum or force times time, then you can calculate the impulse. And we have everything we need to do so on the right side. I need 0.0459 times 90. That will tell me the impulse imparted to the ball from the club. 4.131. The units are kilograms, meters per second. This is the impulse imparted to the ball from the club. It's explicitly positive. Now, by the way, if you remember the problem that was on the board, it also asked for the impulse on the club from the ball. Well, I don't think it's too big a stretch for you to recognize that if the golf ball experienced a force in this direction, then the golf club is going to experience an equal and opposite force in the opposite direction, suggesting that the impulse on the club will be the opposite of the impulse on the ball. And for your notes, you might want to just kind of put down there that impulse is like force. It's a combination of force and time, so it obeys Newton's third law. It's not like the club can be touching the ball for any longer than the ball can be touching the club, right? The moment the club is not in contact with the ball is not pushing on the club. So impulses obey Newton's third law. Of course, the real question was to figure out the force. And the force comes from setting the impulse equal to force times time. So if I multiply both sides by 200, that's going to give me the force. What do you get, like 826 newtons? Don't want to be hit with a golf club. Think it's going to hurt. All right, there, golf club question. I'm not a big golf fan. The fact that the ball leaves at 200 miles an hour does make it a pretty good weapon. I guess that's why you're supposed to yell when you hit the ball. Somebody might get hurt. Again, it says that the ball is struck when it's traveling at 55 miles per hour. It's in contact with the racket for 5 milliseconds and is returned at 130 miles per hour. So I'm trying to visualize what's happening to the ball in 3 steps, just before it's hit by the racket, while it's being hit by the racket, and after it's being returned by the racket. Now the problem asks us to find the force on the ball from the racket, and we can do so by looking at impulse. This problem has the hallmark information that we talked about for impulse problems, in that it talks about a change in velocity and gives us the time of contact, while asking about force. So I'm going to go back and recognize that there's a cause and the effect, that the cause of the change in momentum of the ball is the racket. The racket applied some force over some time interval, and this caused a change in momentum of the ball. This is the essence of impulse. Now, this problem didn't ask us to find the impulse. It just asked us to find the force, so we can skip that middle step if we need to. You probably need to do it, though. The part that you're going to get wrong is probably what y'all are running off and doing right now. If I asked you to work it out, and I could, I just don't feel like it right now. I'm going to factor out the mass of the ball. It didn't change. The final velocity of the ball was 60 meters per second, minus the initial velocity of the ball, which is 21 meters per second. And that's usually where you guys will make your mistake. Velocity is a vector quantity. I have to indicate direction. So the 60 meters per second I indicated was positive because it points in the positive direction, but the 21 meters per second points in the negative direction and thus requires that I put a negative sign in here. Remember, the racket has to slow the ball down to 0, turn it around, and return it back at 60. So the change in velocity has to accommodate the ball going to the right at 21 meters per second and then going to the left at 60 meters per second. Either way, this equals force times time, which is 0.005 seconds. Yes, I expect you to convert milliseconds to seconds. The rest of this is for you to do. I don't want to do this one. Can you guys do the rest of this on your own, or you need me to do the math? You guys can do the math. Somebody's already worked out the math. What's the impulse? What's the right side of this say? When you get, 81 times 0.0585. It's got to be 4 point something, right? 4.74. Funny, because isn't this almost exactly the same impulse as the golf ball? It's not accidental. The golf ball and the tennis ball weigh almost exactly the same amount. They're being hit by humans who probably swing the thing at about the same, whether they're swinging at the ground or swinging at the air. Can't imagine humans can swing it much faster than that. The impulse on a baseball will probably be more because the baseball has, more mass, and so does the bat. But generally, this impulse should be similar between a golf ball and a tennis ball. Now that's the impulse. It is expressly positive. So if I wanted to find the force, not a whole lot to do here. Divide by 0.005. So I don't know, 900 and something? 947 newtons. Lots of force. Of course, there's an equal and opposite force on the racket. Those of you who don't hold the racket tight learn a valuable lesson, don't you? Because it hurts. It doesn't hurt as bad with the golf club because all that weight's down at the bottom. Hurts really bad with a baseball bat. Anybody who doesn't hold a baseball bat tight learns their lesson the first time. Don't you? Anybody ever hit a baseball and not hold it tight? You learn right away the first time. Don't do that again. Usually after you drop the bat and say some things that make your parents really mad. Or is that just my experience? Because I said some words I was not allowed to say. I was in the 7th grade. I'd heard them all. Been riding a bus for years. All right. Any questions about this one? All right. Now, class, before you start running off and work this out, which I'd like you to do, please understand that there are actually 3 different impulses imparted to the ball. There's the impulse on the ball from gravity pulling it down. There's the impulse on the ball from the ground. And then there's the impulse on gravity as it goes upwards and is slowed down. There are 3 different impulses. I only asked about one of them. I asked about the impulse imparted to the ball from the ground. So you dropped the ball from 2 meters, it fell to the ground, struck the ground, and bounced back upwards to 1.5 meters. The impulse I'm interested in is just that instant before, during, and after contact with the ground. I suspect the ball's traveling upwards slower from the ground than it struck the ground. I suspect that because it didn't go as high into the air. Now you have to figure out from what I've given you what these 2 velocities are. I didn't give those to you. I told you how far it fell and then how far it rose. Now, based on what time it is, I suspect I should be able to hit pause here, go back, fix myself a cup of coffee, and when I come back, you should be able to tell me what the velocity of the ball is just before it strikes the ground and what the velocity of the ball is just after it leaves the ground. And I was frustrated that in sixth period, I had to put something like this on the board to chide them into figuring out what I was looking for. I was frustrated by that. At 6.3 meters per second is how fast the ball strikes the ground. Somebody else tell me how fast it recoils off the ground? Really? It's not like it was a lot different. Nobody? Oh, I'm so sad. It's not 6.3. Yes, ma'am.
I got 5.4.
It's 5.4. That's correct. So I don't have the information written down here for the exact problem you would have to do to figure out how fast it leaves the ground. I was expecting you to use the old noggins up there because the ball climbs to a height of 1.5 meters. The initial velocity is unknown, but the final velocity when it reaches that height is 0 under an acceleration of negative 10 meters per second squared. It is largely the same calculation, just that the displacement is now 1.5 meters. We want the initial velocity, because this is the velocity it leaves the ground with. Test Friday, right? Test Friday. This is old school stuff from September and August. So I am not asking too much. And before we're done, we're going to have a projectile motion problem here too. Involved with a collision and some impulse. It's going to be all mixed up on the exam. So to actually do the question I've asked, we now have to, oh, I don't want that. That seems largely obtuse. I don't want to do that either. Stupid thing. There we go. So let's work the problem. I need to figure out the force.
Teachers and students, please pardon this interruption. Teachers, this is just a reminder that progress.
I want to remind you that in this question, the hockey puck is traveling to the right. It enters the region where there's a square dotted line where the hockey stick strikes the hockey puck quickly, imparting a force to the hockey puck, causing the hockey puck to now be moving upwards or towards the top of the page. Now, the force from the hockey stick has to be one of these four things. You have to pick the right one. So, just for fun, raise your hand if you think it's A. B? C? D? All right. I want you to think about this for a moment. The hockey puck is traveling this direction. The impulse has to stop it from moving that direction because afterwards, it's not moving that direction anymore. It's not moving to the right at all. So there's going to have to be some force in this direction. But also, it now has a velocity in the y direction. Didn't have a velocity in the y direction before, so there's going to have to be some force to impart a change in velocity in the y direction at the same time. Which is why the hockey stick must have applied a force in that direction. The correct answer is C. On a test, I'll get you. I promise. I will get you. Because I'm going to ask the question different. I'm going to tell you the direction of the force and ask you what direction the hockey puck recoils. Promise. Now, you guys are